All right, and we're all seeing my other screen. Great. All right, so format of today, we're gonna review homework. We're gonna go over some date, time, and lubridate stuff and get into function writing. So jumping into the homework last week, I haven't had a chance to look at any of your homework if you submitted it in GitHub yet. So my plan is just sort of to talk through how, this was sort of one of the more nebulous questions, I think. And so just sort of talk it through and give you guys a chance to ask questions that might have come up or kind of troubleshoot this when to do what sort of thing. All right, but the general assignment showed you this ggplot and said, and I gave you some data, the Gapminder data, and said, all right, try to recreate it. So it kind of mimics, I think, what happens a lot in real life, which is you might have this like vision of, I want a plot to kind of look like this, and I have my data, and how do I get from data to ideal plot vision? So just kind of walking through this, I'll say one of the first steps that I'll normally go through is like, what should my data frame look like? So if we start with, say, our Gapminder data, and we check it out, we know what this data frame looks like. We can get a sense for what the column names are, what kind of values we're looking at. But given this end vision, you say, okay, what do I want my data frame to look like? What I sort of think about is, okay, on the y-axis, what we see was that change in population between 2002 and 2007, which means that we'll probably need to get a column for each year. And so that it says, okay, maybe I'll have to pivot at some point. You want your x-axis to have countries as rows, which at least is already true. And for the facet, we see that these are faceted or in multiple different boxes per continent. So, but not all continents. We actually have 5, as we can inspect in a little bit, but includes only 4 continents. So this is sort of where my head goes first, is how do I move my data around and filter and select it to get it down to sort of this vision. So what I did, and there are going to be a variety of ways in which you can do this, but we can kind of talk through if there were any questions. But we would start with our Gapminder data. We would pipe, and the first thing that I would want to do is, because I know what variables I'm interested in this population change, I don't actually need my life expectancy or my GDP variables. So I'm just going to, I like to kind of select that out of my data. So you can remember, use this negative sign in select to get rid of a few variables of GDP. And next, I know that I also am only really interested in the difference between 2002 and 2007. So we can see that there's kind of a huge number of years, but I only want the years for when they, and there's a few different ways you could do this, but I'll usually use the in sign within a concatenated list of 2002 and 2007. And I'll probably filter again, because remember, I also don't want that Oceania continent. So I'm just going to go ahead and say when continent does not equal Oceania. And we can already kind of check this out, I guess, and say, all right, we have a much smaller data frame. We have the columns that we wanted. We presumably have filtered out the rows we don't want. And so you can kind of keep going with this, which is the moment of pivot, which I feel like is often really important for getting your data in the shape that you want it for plotting. And so we went over these a few weeks, but, or rather a few weeks ago. But remember, we said we want our year, or we think it would be a good idea if you want to do a subtraction between the 2 years, to have them each in their own column. So we're going from this long form to wide form. So we're going to go wider. And we want to take the names from the year column and the values from the population column. And lastly, we want to create a new column, which we usually do with our mutate function, that we'll just call population change, which will equal, and in this case, because the column names, if we run just this part of the data, what we'll see is that we've properly widened the data, but our column names are numbers now. And when your column names are just numbers, R will include sort of these ticks that you want to remember to include in your names, or else it won't. Like if I just try to do 2007, it reads it as a number, and we want it to be reading as a column name. So what we end up, if we kind of put all those pipes together, is the data frame that we really want to be working with, which is now we have this population change variable between 2002 and 2007 for the continents minus Oceania. Does anyone have any questions on this thought process of how to get the data in the form that you kind of want it?
Just that is a lot cleaner than how I did mine.
And yeah, but and this was definitely something, this could have taken 40 lines of code, really. You could, broken down every single step without pipes, with pipes, and it takes just time, I think, to kind of get into that groove. But yeah, and even within this, there are probably 10 different ways I could imagine doing it. But if you can get to this data frame, then you're doing great. Okay, so sort of part one, I think, is getting the data how you want it. Part two is, all right, how do I make the picture that I want? And the good thing is, if you can get the data how you want it, the picture is typically the easier part. So some of the things that we mentioned that are important to think about is ordering the bars. We saw that these were sort of all ordered in, the countries were not in the same order, but they clearly were ordered based on the population difference. Getting a good color scheme, working with a theme, and rotating the x-axis. So if we start with our PG data frame and we go straight to ggplot, this first part is hopefully what we're a little more comfortable with now that we've done in class the past 2 weeks of our aesthetics, setting x equals to, I'm going to start with sort of the most base version and then we'll build on this, but x equal to country, y equals population change. And you may have Googled around for this. I don't know that we actually have gone over GM call for column, but so there are a few ways you could have gotten to a similar visual. We've been using GM bar, which is maybe something that you Googled or played around with, where you set an aesthetic where you fill to the continent color. And if you tried to run this on your own, you would realize that the bar geom does not actually take an X and Y argument, but if you set the stat argument to identity, it will use your Y argument instead of its count. So you also could have used geom call here, which I think was in the actual answer, in which you don't have to do that. So a little easier, but I think we introduced bar a little bit more, or maybe not. And kind of this last step, you would want to facet wrap. And we said facet wrap by continent. And if you just run this, which I feel like is kind of the basic idea of how to get to this, kind of at least get towards this idea, you end up with something that still looks very far away from what we first presented.
I think you did 2002 minus 2007.
Okay, I was like, oh, and they're all negative. I should have caught that. Thank you. I was like, this is really far away from what we should have seen. All right, so I subtracted wrong, so we had all negative numbers, but now they're at least positive, but this is still pretty, the moment it loads, not what we're looking for, right? In large part because of this scale issue. You see this one, a measurement from Asia, and it's sort of, we're all scaled at this, exponentiated number that doesn't really help us out for hardly any of these other continents. So this is where we'll just add some of our fancy footwork to our ggplot. And I'm just gonna copy this one down so we can add to it. So sort of, I would say base plot. All right, so a few changes which were one, let's say if we go back to our list, is ordering bars in a certain way, you may have found online that there is this reorder function, which will take two arguments. And one is sort of is what would typically be your X argument, the thing, or wait, is it the other way around? Yeah, what you would typically want on your X-axis, like what the category is. But then your second argument in this reorder function is going to be the thing you want to order by, which is usually something numeric in this case. And so if we want to order by what our Y variable is, this will then order them in relation to the population change value. So that's that fix. A few other ones, just getting our colors going. Oh, did I do this not in base plot? Well, sorry, everyone. Kind of pointless to repeat it. All right, so we reordered. To add colors, we're going to use these arguments, or I guess, I don't really know if they're arguments. I guess they're additional functions that we went over last week, which there are a whole variety of ways of coloring, but the one we're going to use here is scale, fill, varieties, and then choose discrete for kind of these discrete categories, and we can just leave that empty. We want to set a theme. I think we presented black and white. You could have used classic or something else that just made it look a little more sleek. And we also talked about this, or I guess one thing that wasn't mentioned, but we want to get all of these to different scales, which is that within Facet Wrap. And again, you can always inspect these sort of things, or a lot of this comes from Googling, which is really just how to get different scales in Facet Wrap. But there is a scales argument within Facet Wrap where you can write equals free. And I think we're getting pretty close to what we want, except not quite. Right, so I think we've done everything except work with the X-axis, and we're almost getting there, but we have all of this overlap. So you could have snagged this from code from last week or snagged it online, but we just want to kind of label our axes and add some themes. So remember, theme is the function that we use for text. So axis text X equals element text. And in this case, we want to set it at a 45-degree angle. And this actually horizontally adjusts it, which moves it over to 1. I think we also, within these arguments, took away the legend position. And then just to add a few labels, like I said, there are a lot of different ways you can do this. I think I usually do labs. And then within that, you can do, I think you can do this. I'll try. X equals country and Y equals change in population between 2002 and 2007. So let's see. And yeah, so, and some of that code might look a little different of what's the answer on the website, but that's sort of the point. There's a variety of ways you can do this, but that's a somewhat quick review of how to get to this end result. But any questions on these different components of ggplot, or sort of how to think through these, or who couldn't find the words to Google some of these problems, what things came up, if any? All right, cool. No issues. All right, great. So we're then going to move on to sort of part 1 of class, which is working with dates. And if any of you have even tried to like plug in dates into Excel or do anything remotely complicated with dates in Excel, you know that computers and dates have kind of a weird relationship, or maybe have a relationship that is beyond our comprehension. Like sometimes I've had some pretty negative experiences, but We will deal with dates in a lot of the data that we collect. And so understanding how at least R, I can't actually speak to how Excel interacts with dates, but how R interacts with dates can be super helpful, because these can also be data types that will actually can get really easily messed up, and you might not even realize it until it's kind of too late, or you're well past working with dates. So first, it's just good to know that there's sort of, I would say, two ways of thinking about dates, or we'll usually say there's date and there's date time. So dates are self-explanatory. They are usually formatted in like a year, month, date format, or that's how at least R and many computers will like it, as we'll see in a moment. And then there's also date times, which are combinations of dates and times. And I'm just going to say that there are two different formattings for this, which is POSIX CT and POSIX LT, but we're really going to focus on POSIX CT. And I'm saying these words only because they will be relevant in the functions that we'll be using. So this is a general, like these are kind of the fancy words that might come up if you're Googling things about times, but the takeaway is that there are dates and date times. A general recommendation when you are entering in data, or if you have control over how your dates and times are entered into the data that you have, the recommendation would be to put each unit in its own column. So this will probably make your life a lot easier, but you'll see there, even if you don't do this, there are ways that you can set yourself up for success, and hopefully ways that you can correct any mistakes you might have made in the past. Cool, so some dates. Let's go with dates 1. Dates are usually indicated by like dashes or slashes, but in the end, they'll usually be first represented as characters. So I'm gonna make a quick, gosh, what are the dates? A string of dates as characters, 2019, 7/13, and 2019. Coming up with dates is hard. So here are some general dates that are just made up. We can see up in our environment that these are characters right now. But in base R, there is a function which is just as date with a capital D, where you can, and we'll assign it to something so you can see this. So if you just use as dates to dates 1, you will see that dates will change from a character to a new kind of data type, one that we haven't talked about yet, which is date. So that's at least nice. You can check that out if you want. Class of dates 1 is a date. And so that means that R is reading it, as this particular data type. So you will also be able to manipulate it with date related functions. However, that seemed really easy and not very prone to error, but I will say R liked this because we did it in the right format. If, for example, you have dates that are in the opposite format, so maybe we're really used to writing things with the month first, so 05, 22, 2020. All right, so we have another set of dates where we've written the month first. They look like a character, that's fine. But if we try to make these dates it says error in character to date, character string is not in a standard unambiguous format. So what this is really saying is that it's not in the format that we like. We expect to see, really 4 digits, dash 2 digits, dash 2 digits that are within the range of dates, but we cannot make this a date, really. Luckily, however, so as date will not make this into a date. But what you will see is that as date, sorry, I'll move this down for you. What you have is an argument within that, which is a format argument, which does mean that within the as date function, you can specify the format that you're feeding it. So you say, this is a date. I know it's a character, but I'm going to tell you the format of this character string, and then you'll read that as a date, hopefully. So let's say we take our dates 2, because this is still a character string. And if we try to now use our asDate function with our dates 2, but we're going to use format equals, and then we're going to use kind of some weird symbols that maybe you haven't worked with before. We are going to indicate month, days, and years, but with percentage signs in front of them, and then using some abbreviations. And I'll give you a little cheat sheet for these abbreviations in a second. But we're going to say my format is $month dash $day dash $year. And let's see if it likes that. Okay, I didn't get an error. We see a conversion to date. And we now see that dates 2 spits out what look like reasonable dates. And they look exactly like the character string. Do they? Rather they have said, okay, we read your months, days, and years. And the date that we're happy with, we're going to put it into our standardized format, but at least we know where to draw these values from. Now I'm going to paste in a cheat sheet for this and open it up so we can look at it for a second. Because so what this $, kind of this vector of $, dashes or M's and D's and Y's is called is strip time, which is sort of just these symbolic representations of what a data type might look like. And if I pull just this little cheat sheet into my screen share space right now, it's a pretty short list and most of it is pretty intuitive, D, M, and Y. There is also this B for month as it's written, so think Jan or January. And I've also noted that there's upper and lowercase y's for digits with 2 and 4 years, although I will say that when I've experimented with this, asDate is actually not that picky, and it will accept, in my experience, a 2 or 4 length year with either case Y. If you find something different, let me know. But this is a pretty helpful and quick thing to remember, nothing too much to memorize, and it can really kind of do wonders as far as getting your dates to the form that you want them to do. So I'll give you just one example of how sort of powerful this is. All right, so let's say, what if for some reason we have a date that is May, but then we have separated with the letter A, 21, the letter A, and 2011. So if we were to use this, what we know about formatting and asDate, if we actually put this in as our date that we wanted to convert with a certain format, we could give it the format argument. And it's pretty flexible in that it will recognize characters other than just the M and D and Y. So you could say this is going to be a month, but then there's going to be an A in between it, and then a $, and a day, and another A in between it, and a $, and a year. So will this give me what we expect? And if you look down here, it has converted what conceivably couldn't have been translated. You use this format argument to translate into a date format that R will recognize. So really quick, something for you guys to take just sort of 2 minutes and do on your own, so you can sort of get a hang of this formatting thing, is if you were to have all of your dates formatted, say an abbreviation of a month, the day, comma, and the year, can you work with this in asDate? So you can type in Joule 4 2019, comma 2019, and what would you make as your format? So just take, a 2 minutes to think about it, get comfortable with these functions. All right. Does anyone want to say what format worked for them?
I guess I could go if no one else wants to. So my format was in the quotations %B and then,
Uppercase or lowercase?
oh, lowercase.
Okay.
And then a space, a %D lowercase, a comma, and then a %lowercase y.
Okay, let's see. Well, I said that uppercase versus lowercase didn't really matter, but what this gave us was 2020 to the 4th of July. Did you get that too, Kira, or did you get a?
Yeah, I don't know why it went up a year. I'm not really sure what happened.
Yeah, so I think I was having some errors yesterday when I was playing with AsDate, and I updated it and I made a lot of assumptions based on what must have been an old version of something on my computer. But yesterday, the Y capitalization didn't matter. And today, so Kira had a lowercase y, and we saw that it actually captured, it bumped it up to 2020. And my guess would be is that the uppercase, although what did that cheat sheet say? It was uppercase. This says that uppercase is 4-digit, whereas lowercase is 2 digits. So if you use the lowercase, it actually may have only grabbed the first 2 digits, which conveniently looks like 2020. Whereas if I change it to an uppercase, it actually knows that it's talking about 2019. So, and ways to experiment that could be if you also capitalize the B. See, it isn't as finicky, like the lowercase or uppercase knows that this is July, but it does seem sensitive about that Y. Did anyone notice any less finicky things? I'll say I've played around. Do spaces matter? And I think that the format is pretty lenient. But I guess I'm nervous to say that because, again, this is where you could make an error and not quite catch that switch from 2020 to 2019 or in reverse, right? So testing and really knowing, particularly with the date formats that you're plugging in with your data, is a good tip. Did anyone learn anything different than what I've just said in their brief exploration?
For me, if you capitalize the B, it just says NA.
Yeah, so it doesn't like it.
Yeah. Also the same with all the letters except for Y. If you capitalize them, it just doesn't work.
Okay.
And
It
so
doesn't like capital
For
D.
me, the capital B and the lowercase b produce the same thing.
Yeah. And that's true for me too, but I will say just like restarting different versions of things as of yesterday have been getting me slightly different results. So this is a PSA to, at least if you're working with data of yours that has dates, make sure you're updated and you know how it will behave with whatever formats you're going to use. And
Sorry.
no,
I also found that the location of the spaces matters.
huh. Yeah, so you'll
The
see.
space between the % sign and any of the letters, it doesn't seem to like that.
So you're saying this won't work.
Mhm.
Yeah, I think the % sign is used to really indicate that this is going to be one of these like special month, date, year characters. But I think spaces in between them don't really seem to matter. So some spaces matter. I think, feel free to play around and tweak with that as you learn. All right, cool. So we said these are dates. The next thing that we're really working with is date time, which is just a combination of dates. And now we're going to extend this also to minutes, hours, seconds, etc. So let's make some date times. These are as a vector that's kind of a pain to type out, but okay, so let's say you have a normal year, month, date format. And then we also, let's say, have observation times, which will type out hours, minutes, seconds in military time. Okay. I'm just going to do 2 of these because these take quite a while to type out. But so we have dates and times that to start, just like our date vectors are just characters. But we can convert them as we did with date time using the function called as.posixct. So this is why I mentioned what we're, kind of these variety of different POSIX date time formats. But we're going to stick with POSIX CT, and we will specify that we, just like with as date, we want to take our date time, and we'll see time come up. It is now a POSIX CT data type, which is a good sign. And it more or less keeps our same formatting, except it tacks on time zones for us. These random dates that I chose are interesting. So I will say it will choose the time zone that your computer is currently in. So this is a giveaway. I'm on the East Coast. Most of you will probably be getting Pacific time on yours. But it's also spitting out an Eastern Standard Time and an Eastern Daylight Time because I accidentally randomly chose months in January and months in August. And so it will actually adjust for dates and months that are in either standard or daylight savings time, which is pretty smart and useful. But let's say my computer's on the East Coast right now, but I actually collected these data in Pacific time. You can go ahead and, just like with format, add an additional argument. So time in PT is as POSIX CT date time. And it already prompts me. You can see there's this TZ equals argument. So TZ equals, and in quotations, I am going to choose America/Los Angeles, because this is, I'll give you a list of these in a second. But when I do this, we'll see that our new date times are presented to us in Pacific Standard and Pacific Daylight Time. So pretty cool. Notice it's not that it adjusts the time, it just adjusts the time given the time zone that you want it to be in. So just time zone. I had a heck of a time. So yesterday I was having errors with any of these time zones working. So if any of you are getting errors right now, hopefully you aren't, but it might be just an update and reinstallation of, or really just an update of things. I just sort of had to close out of R. But I did get into kind of a wormhole of how do you actually find what all these time zones are, because it wouldn't necessarily be intuitive just to write America Los Angeles/Los Angeles. And actually, if you did asked it to do PST, it tells me that PST is not a time zone, which is fairly frustrating because it very much looks like a time zone when I execute my time zone. So I was reading a bunch of Stack Overflow comments. One of them was like, yeah, they just have really weird names. But I finally found a function that seemed, I tried some of these, but Olsen names with capitalizations seems to spit out at least what is a very believable looking list of time zones. So if you are collecting data wherever, these are some of the vector, or I guess the characters that you can use to represent time zones. Okay, any questions about dates? Or no, not dates, times. All right, we look good. So I'm going to take the last 8 and maybe go over even 10 minutes to talk about. So a lot of the time in this class, we'll present a concept to you using some of the base R language, and the as date and the as POSIX CT are the base R, and you might get code from someone else or come across different forums where they are using these functions. And I think it's always helpful to know that this is one totally useful approach to doing it. And then we often present a second, what we may conceive as a more useful approach to doing it, but knowing the syntax of both functions and what kind of packages go with what is always kind of a good thing to start categorizing in your mind. But Lubridate is a package that makes some of this a little easier, at least gets you past this some of this formatting language. So if you haven't ever installed Lubridate, I'll do it down, at least type it in my console so that it doesn't have to remain in the code. You can install packages. And remember, we do this in quotation marks. Lubridate is spelled like that. So we can take a second there. I'm not going to run that because I've already installed it. But once that is installed, no, that's not what I want at all. We can do library lubridate and load that in. Just real quick, can we just get a check-in, a deep breath, and green stickies if you have lubridate now on in your R session? And a red sticky if you are even, still on errors from POSIX CT. We'll see. All right, if TAs want to check in with at least one sticky. Okay, we're almost there. We'll catch one or two of you up real quick. Okay, so we've loaded our lubridate package. Now, how does this work? So let's create some more, get another kind of sample dates. And let's this time say we're going to use a format that we like to use. We like to put the month, day, and then the year first. And 3, 15, 20. All right, so this is how we entered our data. It's how it's easiest for us to read. But now, instead of the as date function, we can use functions that kind of look like formatting calls, but without the nasty kind of percentage sign situation. So let's say our dates in lubridate, how this function starts is I'm going to basically just tell it the format of the date. So it is month, year, date, and why this is not popping up is okay. I was curious. It wasn't tab completing for me. But so month, year. In this case, we'll do month, year, date. And then we will put our dates into here. And we will see dates lub. Oh, no. Did not like this. Let's see what happened. Oh, maybe it's because it's not month, year, date at all. Thanks, guys. So we did month, day, year. That's the actual format of those dates. And yep, it turned it around. And so instead of doing this as date and then specifying the function with the dollar signs, et cetera, all you have to do is tell lubridate very intuitively what that date looks like. And if you check out lubridate, I'm struggling with my spelling today, clearly. If you check out, lubridate, and you can see kind of the whole list of functions. This is one way to inspect functions or expect all the functions in a package. But you'll see that your options are pretty expansive. You can do day, month, year, down to hours, minutes, seconds, day, nanoseconds, day, seconds. The sky's the limit here. So lubridate is a really helpful package in this sense and is just kind of a lot less clunky. And you can do the same, let's see, is AK Alaska? You can do the same TZ argument in there. So if you take your dates, but you want to set the time zone to US, Alaska, your dates. Let's see. So we now have set this to Alaska Standard and Daylight Time. So the same TZ argument, but not the same format argument. And so what we're going to do now, right before our break, is we are going to download a data set that we're just going to experiment a little bit with their dates. And oftentimes, so the way we started this class is that we actually put some data in a data folder for you so that it was at least easier to navigate in your working directory. But a lot of the time you're either emailed a data set or it lives somewhere else on your computer and you kind of need to get it from point A to point B. So before our break, we are going to find and download data from the R Davis website, put in your R project data folder. So this, is a good habit to get into if you're not, if you haven't done this before. But on the R Davis website, hopefully all of you can pretty quickly navigate to this. I usually just, I think if you Google R Davis website, or if it's not already open, it's pretty easy to find. And then on the resources tab, if you've never checked this out, lots of really great resources. But we also have all of the data sets and more that we have used for this class. And they're really great if you ever just kind of want to experiment with things. But at the very, very bottom of this list, we have a Solunst data set. That is, what we're going to do is we're going to click on it and it will automatically download a CSV to somewhere on your computer, wherever that might be, whether it's a downloads folder or maybe it automatically downloads to your desktop. I'm just going to open it up. So we will look at this actually in R, but I'll mention right now that it looks a little wonky and maybe not in the tidiest form, but I am going to save as, and then I'm going to put this CSV in the data folder of my R project that I'm working on right now. So for you, this should be the R project that you have been working on. My navigation is going to look a little different because Christian and I actually do not have this yet in our box folder, except we use Dropbox. Aha. Did you know Box and Dropbox are different things, which we had an extensive conversation about once. So I'm going to find the data folder in my R project. And so the name will look a little different, but generally, whether you have a data raw, if you renamed it, and we're going to keep 2015 underscore NFY underscore Solunst, and we're going to save it there. And so that is all set up for some quick and fun post-break Lubridate exploration. But go ahead, get that downloaded. And once you do, we'll reconvene at 10 after the hour. And if you have any issues, we'll be here to make sure that that CSV gets into your data folder.
All right, the recording started, so I will take that as my cue. It looks like there's still a lot of blanked Zooms, so maybe people are still rejoining us. But so before we went on our break, Liza directed you to a data set that hopefully you have downloaded and stuck in your data folder. So I'm not sharing my screen. This is not super helpful for you yet. Let's see. Okay, so if I did that right, you should be looking at my RStudio and I'm getting a thumbs up. That's maybe too big. Let's go with that. And so hopefully you have in your files tab over here for your R project, you have a data directory, and then inside of that, you can find your 2015 NFY Solunst data. So the idea here is we're hopefully going to show you why we actually care about having data formatted in this sort of date time setup. So the first thing we'll want to do is import the data set, and we will, for the time being, call it NFY1. And we'll use our tidyverse approach with read underscore CSV, and then direct R to our data subdirectory. And then within that, we can find the NFY Solunst data. And you might have noticed when Liza first opened up the little preview of that file, there were a bunch of lines at the beginning of it, rows occupied with information about the data set. And I just happened to know that there were 12 of those. So we're going to skip equals 12 so that R knows not to try to read information out of them from like a data frame perspective. So the first thing we want to do when we import our data is to look at it in some way, use your preview du jour. I'm going to use head because Liza and I just talked about that one. And we can see that we have a date column and a time column, this unknown MS level and temperature columns. And you can see that when we used read_CSV, the time column is already formatted in this time format. However, our date column is in a character format. And so that's not set up as a date type column yet. So one thing that we can do with read_CSV is declare upfront what we want the columns to be read in as. So rather than using read_CSV and the arguments that we had above, we can also include a call types argument. And then we will list basically each of our columns get a 1-character abbreviation for what we want them to be. So our first column, let's import that as a character. Our second column, let's import that as a character as well. And then we will use, I'm not even sure what the I is. It might be integer. And then we'll do level and temperature will be floating point doubles, which we've talked about before. And I didn't skip any rows, so R got super confused because there's a bunch of stuff that was just 1 column wide at the top. So we need to remind it to skip equals 12. And now if we look at it, NFY2, we can see our date column is a character, our time column is a character, and then we have integer and double for the MS level and temperature. So if we want to take this separate date and separate time columns and generate a single cohesive date time column, one way we could do that is using, rather than like a tidyverse approach, we could use base R and assign a new column with the $. And we would do that by, and if you recall from, I don't even remember when we talked about this, but you can pull out individual columns using the $sign with an existing column. Or you can assign new columns, also using that, but with an assignment arrow. And so we'll say, I don't know why I keep wanting to use an S, NFY2 $date time, and then we'll assign that to be, and we'll paste 2 existing columns together. So we'll take NFY2 by date. I did an S again. Date. And our second thing that we're going to paste into this is a space. So we'll just add a space. And then we'll do NFY2, oh my God, by time. And since we stuck a space in there already, we'll say we want these things to be separated by nothing. So we'll put just 2 quotation marks to indicate that there's nothing that will separate each of these arguments that we stated. And now if we look at head of NFY2, we'll see that we have our original date column, our original time column, MS level temperature, and then also this date time column that is a type character, but it has all of that information from our original date and time separated by a space. So next, I believe what we're going to do is convert this to an actual date time, and we can use some lubridate fun for that as well. And first, we're going to test it because we don't actually know if this is going to work. So we'll call it date time test, and we'll say as_date time. And this is just looking for one argument. You can see here it asks for as date time X. So we'll just give it a shot and say NFY2 our original date time. And let's see what this gives us. All right, it wasn't happy with that. Maybe it's because we didn't include a time zone. So we can try TZ equals, is it America / Los Angeles? I'm missing an underscore. Okay, it's still not happy with that. Something has gone horribly wrong here. But it looks like, did I do this dumb? I'm not totally sure why that didn't work. It might be because as datetime doesn't know exactly what to expect. So we can look at the documentation and let's see, as datetime. Squirrels chasing each other above me. I am not going to be able to figure this out in 2 seconds, so I'm going to move on. And
Christian,
do you
I
know?
think it's because, so as datetime, like you're not specifying the format, whereas potentially in the next line of code, you could go with the like, you know, whatever this is, which is month, day, year, hour, minute, second, and do
I see.
that next thing. But I think that as datetime probably has a particular format that it's expecting, and I think you're not meeting it. So I wonder if it's expecting that default like year, month, day for like, I'm also looking through the, it wants a POSIX. I think it's the wrong format.
Okay. Yeah, so we can sort of circumvent a lot of these parsing issues by just being more explicit about how exactly we're feeding Lubridate these date time information packets that we have that it doesn't totally understand yet. So we know that our data is formatted in year or month, day, year, and then hour, minute, second. So we can say MDY_HMS and try this with NFY to $datetime. And once again, we'll specify the time zone is America/Los Angeles. And now we didn't get an error, so that's maybe a little bit reassuring at least. And let's take a peek at it. All right, we got a bunch of NAs because I'm actually not sure why this is unhappy with this. We might be able to overcome that. Can we declare format? Whoa. Format equals, let's see, %m/%d/%Y, right? No, lowercase y, space %hour, :m, %s.
Christian, it might be the time zone portion of it. I just took that out of my code and it ran okay.
Interesting.
Yeah, question is this working for anyone? Because I have an idea, but
Yeah, actually the initial datetime_test worked fine for me. I didn't get an error.
Me too.
Lubridate's been weird these days, guys.
Then I undoubtedly have a very out-of-date tidyverse. So I'm going to quickly do a workaround for this because, to be honest, I often prefer the POSIX format for date stuff because it's something that I work with and I'm often comfortable with it. But let's see if this works just as a quick alternative. %hour, %minute, %second, comma. Okay, that still didn't work.
Wait, this is a real question. Is Lubridate loaded on your? Yeah, you ran the whole code, right?
Yeah.
Yeah, it is. Okay.
I think you're missing a % in front of year.
Thank you. Oh man, collaboration is so wonderful. Okay, so we now thankfully have a date time column. You may have gotten there in a different way using Lubridate. The base R can sometimes be a good fallback if there's weird package conflicts and things don't want to talk to each other. And at the end of the day, if you have something that you created as a datetime object with base R, the tidyverse will still understand it as a datetime object. So you can kind of bounce back and forth sometimes. Let's see. Okay, so there's some really cool stuff you can do with the tidyverse. For example, we have a date column now and a date time column, but say we want to pull out monthly data. Well, we can create a new column called NFY2 $month and use an assignment arrow to extract only the month from each of our datetime elements. And Lubridate has a function for month, for year, for day, for hour, and I think for minute and maybe even second as well. I wouldn't be surprised because they're pretty comprehensive, I think. But let's give it a shot. NFY2 $datetime test. And let's look back at our NFY. And it's too big, so I'm going to open it up in the new panel. And we can see now it has extracted our 5th month of the year for at least the top majority of the data. I'm sure it goes on. Yep, here we're down in August now.
Hey, Christian, we have a quick request to save the live code.
Sorry, I just, as of the request. Okay, extract subdate info. And ultimately, having stuff saved as datetime objects is, it's useful from a like thinking about your data sense, but it's super useful when it comes time to plot, because if you can't plot character vectors as a continuous x-axis, but you can plot dates as a continuous x-axis. So let's give it a try. We're going to, we'll use our typical tidyverse approach. So we're going to pipe our NFY2 data set into ggplot. So remember, that means that data equals NFY2 because it's being sent directly to ggplot. And we'll say AES X is going to be equal to datetime test because that's the one that's an actual datetime object. And then Y is going to be equal to temperature. And let's add some geom points to take a look at it. That's not very interesting. Does that seem right? Are all of the temperatures 0? Okay, temperature was not a terribly interesting thing to plot. It was always 0. Let's see what level looks like. I'm not actually sure what lives in this data. Okay, level has something going on. But the point that I'm trying to illustrate here is that we have an x-axis that originally would have been occupied by like some sort of nebulous character that doesn't really make sense in terms of space. But we can assign that to coordinates on a plane that correspond with our understanding of time. Oh, the last thing that I want to talk about for datetime stuff, because it's going to be relevant with the homework, is that you can assign time zones to your data. But if you are interested in converting to a different time zone, that's not a matter of reassigning the time zone. You need to actually calculate what the new time will be. So we could say NFY2 $UTC time. And so that would be like, I don't know if that's in Greenwich or it's something European. And oftentimes data loggers and stuff record data in UTC, GMT, whatever your preferred nomenclature for European time is. And if you're trying to pair that with like temperature in California, then you need to consider what the time zone that you're working with is. So we can use, what is the name of that function? I think it's with TZ. Let's see. Yes. Okay, so we can say with underscore TZ, and that will basically, so you can see with TZ asks for time and then T zone. So we will give it NFY2 $datetime test, which is our datetime object. And then we will say TZ equals UTC. And now we can look at the head. No, we can't because it's too big. Let's just jump to the view over here. And you can see that our UTC time is now offset from our date time test columns by, it looks like 7 hours. And I believe that California time is GMT -7. Does that sound right? I think we're more than that.
Does this data think that you're in Eastern time? Because I had it.
Might be. Is there a way to check time zone? It's just easy. Yeah. Let's see, NFY2 $ date time. What's the difference between? Should be 8 hours.
It should be 8 hours.
And this
Might-
is.
Is it like a daylight thing?
Oh, is there no daylight savings time in England?
There is, but maybe it's like GMT +1 or something. Maybe they don't have like a, because it's mean, not like standard or daylight.
Oh, yeah. Okay, all of that is to say, you can convert time zones with this with TZ function. All right, that was a little bit of a whirlwind for the second half of date time stuff. Are there questions on that? It looks like there's a lot going on in the chat right now.
I don't know if anyone else is getting this error, but when we were initially trying to plot the data, I get an error. It says in seek.int and a bunch of things. 2 must be a finite number. Did anyone else get that? Or if not, I can
I
just.
got that. Yeah, mine won't run either.
Yeah.
Oh, wow, a lot of people have problems with that. Let's do a quick sticky check. If you got this with int problem, go ahead and give a red sticky. If you were able to make a plot, make a green sticky. It sounds like Kira might have had success in using a capital Y rather than a lowercase y.
Yeah, in the earlier part where we were making the date time test.
Whoa.
So, 2 must be.
Interesting.
I was kind of shocked. I guess maybe not. It was interesting to me that when you plotted, Christian, even though I don't know what data type your month is, and that's maybe worth looking at because it's interesting that it like plots it it plots it as June, July, August, and it immediately converts this like numeric to factor. And I'm seeing sequence int, which maybe has to do with integers. So like, is there something having to do with integers not representing factors? Maybe not, but it says it's numeric.
Yeah, but also I didn't plot versus month. I plotted versus
that's true. Date time test.
the date time. But yeah, so that would actually maybe be useful for people who are running into this problem. Can you run the structure of your data frame and see if, because now I'm actually seeing my date time test is a POSIX CT, not a Lubridate date time.
What are you wanting us to look? So I ran the structure and which one did you want to look at?
Yeah, so what is the class of your date time test column?
POSIX CT.
Oh, and it still doesn't want to.
No, it won't plot.
Interesting.
But mine, like when it runs my date time test, it says POSIX CT and then format NA, and it just keeps repeating.
Okay, yeah, so that's definitely the problem then. Let's see. So if we go back up here, you can create your date time column, and I'm actually going to reload this data set because there's too much going on. So we can create a date time column, and it should be a character with month/day/ 2-digit year, and then a space, and then hour : minute : second. Is that true?
Sorry, I'm just reloading everything from
you're
the live code. That way we're working on the same thing. Yes, that's true.
Okay. And then when you run the date time test, somebody said they used a capital Y, but that,
My data's has a 2015 instead of 15. Like all the years are 4 digits. So I don't know if my data is just different than everyone else's or something. I got it off the website.
Yeah. So something I noticed if you look at the website, Christian, like for this lesson, the dates are formatted differently than the dates in whatever was just downloaded. So something happened.
okay.
Which is, I think, the root of all of these problems.
Yes, probably.
I can just watch and then try with a false data set later.
Well, it seems like a number of us are having the same problem, so I'm a little bit hesitant to just try to move on. How about if you were able to get this to plot, if you have a green sticky up, go ahead and take a 5-minute break. And those of us who are having problems, let's try to figure this out real quick. So, Liza, you said that the data set on the website isn't the same?
So if you
Oh, the
look at,
format
say, the
is-
lesson and you look at like the quick outputs from that,
Mhm.
yeah, the formatting is 4-digit year, et cetera, et cetera, et cetera, which is not the same format that we are working with now, which is really curious.
So that makes me wonder. I'm going to check the data subdirectory.
But when I do, so let me see if as date time works. So when I do, instead of as date time, when I do month, day, year underscore HMS or MDY underscore HMS, it seems fine. But so does as date time. So
wow. And
It looks like I'm fine until we get to the extract subdate info hashtag that you put up. Between when I run that, that's when all my date time tests and months and everything turns into NAs.
so you had a functioning date time test column before running the month?
Oh, wait, no.
I
just
have,
lied.
Rachel just made a comment that I think might also be part of the root of the problem, which is, if you also notice on the website, and Rachel said this in the chat, that when they automatically load in, when they do read CSV, the automatic reader is a date instead of a character for date. And if that wasn't assigned then with the column, I wonder if something is happening with the assumed date format in some people's version of Tidyverse.
Okay. Yeah, so if you are having problems, did you define the call types as character for date and time?
I did because originally it loaded up as date.
Okay. If you are still working on this, check out the chat for a suggestion from Liza, and I'm going to try that too.
That just stopped working for me, so.
That started working for me.
Wait, maybe so the one thing that's interesting about dates and, no, mine still doesn't work.
When I run that code, it says all formats failed to parse, no formats found.
And that was for the tidyverse solution, the MDY_HMS.
Yes.
Okay, so it may be that your data are imported differently, and if the year is first, which it sounded like at least somebody's year was first, is that true?
Yeah, that's how mine is loaded.
Okay, so you will want to use this same thing, but reorder your MDYs to correspond with the order that your data are shown in.
Okay, so test. No, it still didn't parse. Data test.
Christian, I did what you said and that worked for me.
Okay. That's a little bit reassuring. It looks like somebody raised a hand. Olivia, do you have a question? Oops. So that did work for Monica.
Oh,
But-
you did that. Oh my gosh, I think that may have worked. Monica.
Carly, have you been able to overcome this yet? And then it looks
No.
and Sierra is the other. Did you try the approach that Monica shared?
I'm trying to, but where are you changing the order?
Okay, so you have imported your data and you created a date time pasted column. And so you can look at it and you see there's a character column called date time with all this stuff in it. And then if you look at it and it's not in this order, you will have to reorder the stuff that's in this format here. So like if you have year is first, you would want it to be %y and then %m and then %d, or %d and then %m, depending on what it is.
Okay, it looks like it is in month, day, year already.
And then space, hour, colon, minute, colon, second.
It's just NAs and, wait, I don't think I'm looking at the same thing.
I take it back. It didn't work.
I just tried another, at least I just sort of pasted it in there. It should be, so I found in exercising with this that dates are really finicky. And once you assign them once, they can start like, they're not overwritten that well. Like overwriting certain things on, like it doesn't, they're not as flexible as other data types in overwriting certain qualities of them. So it might also help, like, so I just pasted like a read it in, make sure you assign the column types, paste them together. And if your format is month, yeah, and Monica said about rerunning from the beginning, but I put a little bit of if it's month, day, year in there. So I think it is also, go Sierra.
Sorry, I changed my code to what Monica had posted and did run it from the beginning, and I was able to get the plot now. So
okay,
that worked for me too.
All right, I'm going to start a new script.
I don't know. I'm pretty lost. I think maybe just go on without me and then I'll figure it out after.
Okay. So normally my office hours are on Thursdays, but there's Thanksgiving this week. So if people are having problems with this, shoot me an email and we can find a time to meet and deal with this, because a big chunk of your homework this week will be date time fun. So definitely want to get it figured out at some point. Okay, well, for the few of you that are still having date time problems, I'm very sorry. Hopefully we will be able to get those cleared up sooner than later. But with the last couple minutes of class here, I would like to at least introduce functions. Functions are something that we have used this entire quarter, but we haven't really talked about like how to make them, which might not even be something that you realize, that you can make your own functions. And functions will totally change how you look at R and how you think about R and everything that you do with R. And in the interest of a little bit of self-promotion, I just want to show you a project that I've been working on lately. And I have this whole script called data filtering functions. And each of these are just their own little function that I wrote. And they all do their own thing. And then later on, I can access these functions and run them in my code. And they do a whole series of steps on their own that is code that is written somewhere else, but I can apply whenever I need it. So I'm going to start a new little chapter here, functions. We can write functions to do anything we want. So as an example, something that you could ask your computer to do is calculate sums. And the way we design functions is we say whatever the name that we want our function to be. So an example could have been with underscore tz or ggplot or month or paste. All of these things are functions. And so we can make a function called my sum, and that's going to be equal to a function. And you see immediately function comes out in this different color in RStudio. And there are just a few simple building blocks that we use to actually generate a function itself. So the first thing is an opening and closing parentheses, which we'll come back to. And then the next thing you have to include is a set of curly braces. And curly braces, at least on a Mac keyboard, live above the square indexing brackets. I'm not sure if that's true on PC or not. But these curly braces indicate where the beginning and end of the function is to R, because it needs to kind of understand that there's a little cohesive package. And so if we want to generate a function that creates sums, typically we're adding two numbers together. And so in the parentheses of our little function here, we can tell R that, well, my sum is going to be a function of A and B. And this is in the same way that when you took algebra, you learned that y can be a function of x. Well, in this case, my sum is a function of A and B. And what we're going to do is, within the bounds of this function, say, I want you to calculate A plus B. And we'll call that C. And at the end, we'll say, return C, back to me. And so anytime we run this function, R will add A and B together to create C, and it will return C back to us. So let's give it a shot. We'll say my sum, and then see, it already tells us in our little yellow box, it's expecting an A and a B. And we can say A equals 14 and B equals 12. And if we run my sum of 14 and 12, sure enough, we get 26. Now that seems like a hyper simple example, but there's lots of complexities that you can go through with this. So for example, you could say my sum 2, and you can actually define default values for the different arguments that you feed into it. So for example, you could say, well, I want my sum to assume that A equals 0 and B equals 0. And it will still be the same thing on the inside. And now if we run my sum 2, we can actually run it without putting anything inside, because there are already default values assigned to A and to B. So if we run my sum 2 on its own, we would presumably get 0, because 0 plus 0 is 0. But what's cool about this then is you can say my sum 2 and leave A out and only say B equals 12, for example. And now we're adding 0 plus 12. Or we could say my sum 2 and override both of them equals some crazy number. And sure enough, we get this number plus 14, which ends in a 95. Let's see, what else do we want to talk about with functions for the remainder of class? Okay, so something that R does and is not necessarily true in other programming languages is R kind of assumes that the last thing that you do inside of a user-defined function is what it's supposed to return. So it will actually return without being told to return. And so we could say, for example, my sum 3 is going to be a function of A and B. And we can simply say A plus B. And my sum 3 will understand if we say A equals, I keep using 12 and 14, we'll say 0.6 and negative 432. My sum 3 will still return whatever this computed value is, because that's the last thing that it spit out within the function. And so that is ultimately the last thing that the function will spit out to the end user. Functions contain objects that can be computed within the function, but there's this sort of structure to how R understands what are called scopes and environments, in that if you have an object on your own, we'll call it A, and A is going to be equal to elephant. You cannot add A plus 14 because you can't add 14 to a character vector. But the A that is within the mySum functions, R understands that that's not the same as the A that lives inside of your so-called global environment. So when we create objects in R, they get added to this global environment. But then within functions, each of these functions has its own little tiny micro environment that is kind of separate from our global environment. So I could still call my sum and say A equals 12 and B equals 76. And it isn't going to try to add 76 to elephant, because the A that is within the function that you create is understood to be separate from the A that's in your environment. So I think to finish off class today, we'll do a small little challenge of converting temperatures. So you could, for example, convert Fahrenheit to Kelvin using a function of temperature where Kelvin is equal to temperature minus 32 times 5/9, which gets you to Celsius, and then add 273 because that's the difference between Celsius and Kelvin. And we could say F2K of, we'll say 32 degrees because I think that should be, yeah, 273 degrees because absolute zero is negative 273 degrees in Celsius. But so let us give a shot at reversing this and create a K to C function where you are going to provide the function with a Kelvin measurement, and it will give you a Celsius measurement. So go ahead and spend 5 minutes on this, and then we'll give you 2 minutes in breakout rooms, and then we can reconvene quick before the end of class. All right, I was going to suggest that we go to breakout rooms, but I did really bad mental math there. So in the interest of time, let's reconvene. Did anybody successfully create a K to C function? And can they walk us?
Oh, I did.
Could you tell us what you did?
So I did K_2_C equals function in the parentheses temp, and then in the curly brackets, I have C assignment arrow in parentheses temp minus 273.15, and then another line for return C. Perfect.
Nice. And let's give that a shot. We'll say K to C for negative 273.1. That was dumb because that's less than absolute zero. And sure enough, you can convert right there from Kelvin to Celsius in a single line of code. And you can do it 1,000 times over if you have, let's say you have a sequence from 100 to 200, phi equals 1. And we can do K to C on this whole thing. And we can spit out the result in a single line of code rather than having to do this thing 100 times. Does anybody have questions on the very beginnings of functions? We will talk a lot more about this next week. Okay, super. Please fill out the end of class survey. It's on the lectures tab of the website. Have a lovely holiday. I hope that you find some time to take off and take to yourself. You all deserve it. You've been working very hard. Please don't hesitate to reach out if you're having problems with the LubriDate and POSIX CT stuff. It's a real pain. I fight with it every time I have to do date time stuff. So it's not too surprising that we ran into problems with that today. Go ahead, Liza.
You might have just were about to do it, which is just mention that now might be a good time to look at the final assignment tab because we don't have, so this will be your last kind of like weekly homework this week, and then we're going to give you a couple of weeks to dive in to the final assignment, and there are some instructions, but there's also some new information, like we said, was marked down on there. So we'll give you a little briefing on that, but it's good to kind of wrap your head around how much time this might take, what sort of things you could start thinking about, hopefully to save yourself some end of the quarter crunch.
Yeah, this will definitely be, it'll take more time than your previous assignments have. But again, we're always around. So if you're having problems or just want to chat don't hesitate to reach out because we're here. And with that, it's 4 o'clock. So have a lovely evening.
Thank
Bye.
you.
Thank you.